Now your head's in the way.
Hey, down in front. Get your giant nugget. All right. So, two things I want to talk about. Actually, one big thing I want to talk about before we start the next lab. In the last lab, I just graded it. One of the things it has to do is account for any differences in the spring constant. And I was probably like you this way, like 25 years ago. But human error is not a source of error. I know it sounds weird, like I didn't do it right. Human error is not a source of error. Sources of error are gremlins that creep into the lab or things you can't control. What is one of the things you can't control in a lab in real life? Friction. You can't control friction. So there's changes in amplitudes, and sometimes those end up being changes in periods or frequencies, but you can't control things like friction. You can't control things like wind resistance or time. You can't in real life. But human error, that's not a source of error in any discipline. Okay, so the question I have for you is this. Imagine you're an astronaut or a cosmonaut, and you're on the International Space Station, and along floats by an interesting piece of space garbage. You're like, that's a strange piece of space garbage. And so you take the robotic claw and you grab it, and you want to find out what it's made out of. Now the simplest way to find out what something is made out of is to find its density. What do you need to find its density?
Mass over volume.
Mass and volume. So volume should be easy. You got a container, you have lots of containers. It's an International Space Station, you probably have lots of bins. So you put it in the bin and you fill the bin full of water and you're like, okay, that's 4 liters, and you pour the water out and it turned out to only be 3 liters. You're like, all right, the volume is 1 liter. Easy. Yeah.
How are they going to do that in the International Space Station if there's no gravity?
You mean pouring water or something? They just use pressure. Yeah, use pressure. So you got the volume. Volume's easy, or maybe even it's easy enough, like it's a cube, and you can just like cut a chunk off, and you're like, I can make a cube chunk, and this chunk is 1 centimeter by 1 centimeter, 1 centimeter. That's fine. Volume's easy. How do you find mass in no relative gravity when the floor is falling away from you as fast as you are falling towards it?
You apply a force to it.
Apply a force to it.
So say you know the force, you apply the force, and then you measure how far it moves.
Excellent, yeah. So that is definitely one way. You can apply a force to it. So let's say you have a force meter, and you apply a force to it, and that gives it an acceleration, and you can measure how far it moves during that time. Okay, so there's 2 types of mass that we like to talk about in physics. One is gravitational mass, how much things weigh, the mass that makes a weight. Another is an inertial mass, how mass resists motion. Okay, so that's one way. What's another way? Let's say you didn't have an accurate way to measure any kind of force. What's another way?
Pick it up. Well, that's about 4 boxes deep. And then, it's like 4 boxes.
Is there a mechanism, is there a formula that has mass in its formula but doesn't have a weight or doesn't have a force in the formula? Kinetic energy? Okay, well, kinetic energy is going to have to be 1/2 mv squared, so we measure, to get something going, we have to give it a force to get it going. What have we been talking about these last few days?
Constant of a spring.
Yeah, constant of a spring. So we know that the period of a spring, we know that the period of a spring has the formula what? 2 pi the radical m over k. So that's cool, which means if we can measure a period and we measure spring constant, then we can find mass. I give you the inertial balance, based on a design that one of my mentors designed, and it's way better than what we can buy in catalogs. And yes, these are saw blades. They're just hacksaw blades because you can buy a bunch of them cheap. And what the inertial match does is it acts like a spring, but instead of bouncing up and down, it bounces back and forth. So you just basically pull it aside, it goes boing boing.
Well, that's cool.
Totally cool. So what you're going to do is you're going to get yourself your C-clamp and inertial balance, and your group needs to write down what inertial balance you use, because we'll be using this for the next 1 or 2 days. So you write down which inertial balance you're using and what side you're clamping down. So this inertial balance is marked 6A and 6B. So it's inertial balance 6, and I'm going to clamp it down on the 6B side.
Sorry, you should have told me.
No, I haven't
For that,
In the asterisk, right?
no, you just label this on
All right, so this is my inertial balance. There's nothing on it right now, so it goes back and forth. You can see it go back and forth.
Yeah.
Hands back and forth. And we care about the period. Now, it's going to be kind of hard to see the period, like, okay, 1, 2, 1, 2, 1, 2. So what you should do is have somebody in your group count or have a stopwatch for 10 seconds, and then somebody else, like, say, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many did you get in 10 seconds? I got 25. Okay, so 10 divided by 25 is the period. Make sense? All right. So does the mechanism of the inertial balance make sense to you? All right, so the goal here is this. We want to know what mass of odd objects, what they are. We want to know what the odd object mass is. So, like, what's the mass of this Rubik's Cube? What's the mass, this is a, what's the mass of my livermorium?
Wait, so then you put it on the board?
Yeah.
How do we
That's
get
cool.
Yeah, exactly. First we need to get K. So we need to get K and find out what it is. So what we're going to do is we're going to create what's called a calibration curve. We're going to put a mass on it, like so. And we don't want the mass to move. And then we're going to go see, we don't want the mass to move. Yeah, we do not want the mass. So you might need to make a little tape sarcophagus for it. So ideally the mass does not move around. So we don't want the mass to move, and what we're going to do is we're going to go, okay, 100 grams. Again, have some of this timer for 10 seconds, you count how many buffs you get. And you're going to make a graph.
Oh, are we able to use masses to start out with that we already know? The
Yes.
exact mass?
That's the calibration curve. So you're going to say, all right, at 0.1 kilograms, I had a period of this. Actually, back up. Period's going to go down, so period's going to be right here. And then at 0.2 kilograms, should the period go up or down? Down, because mass is.
There's mass
On top.
increase.
Yeah, mass is on top. So period should be right here. So at 0.2 kilograms, your period was this. And at 0.3 kilograms, your period was this. And at 0.4 kilograms, your period was this. And at 0.5 kilograms, your period was this. And we're going to stop at 0.5 kilograms. And I found out about 3 or 4 years ago that anything more than that, the springs start failing. So that's a calibration curve. And you're going to like, all right, you're going to put it in Logger Pro, and it's going to go whew, but it's not going to go to 0. It's actually going to have a y-intercept. And there's a question in the lab about, what does the y-intercept represent? I'm not going to answer now. Okay? That's what you're going to do today.
Okay.
Make sense? And then tomorrow, you're going to get a bunch of random objects. You're like, wire strippers, how much do they weigh? And you're going to put the wire strippers on their inertial balance. Boop, 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 boop. And it's going to be like, okay, the wire strippers gave me a period that is that. How do you find the mass?
Go to the line.
Yeah, just go over and go down. Simple, right?
Crazy.
Okay. Questions? Yes.
So you said that they use this in space to find mass?
No.
Oh.
They use a similar, they can use a similar device. But no, this is, the point of this activity is that you can find mass, you can find inertial mass without gravity. That's what you're doing. Right? So are we cool?
Uh-huh.
All right.
Yep.
Okay, go ahead and hit the silver button on the camera.
RBA.